Starship delayed, the first solar eclipse to grace Australian skies since 2014, a student-led lunar rover, and some fascinating news from deep out in the universe.
This is Trekzone's Talkin' Science.
This is the Bite-Size Podcast, catching you up on the latest science and space headlines. The first fully stacked Starship had its initial launch window scrubbed, thanks to an issue with the pressurization system in her first stage. The SpaceX rocket, the largest ever created by humanity, is aimed at taking people and cargo to the Moon and Mars. A new 62-minute launch window opens on April 20 at 11:28pm Australian Eastern Standard Time, or 9:28 US Eastern. The plan is to see Super Heavy, the first stage, make a hard splashdown in the Gulf of Mexico before Starship, the upper stage, makes a partial lap around the planet, coming down in the Pacific Ocean off Hawaii's coast around 90 minutes after liftoff. The time of the first solar eclipse to grace Australian skies since 2014 is almost at hand. Professor Michael Wheatland telling the Australian Science Media Exchange, for most of Australia the eclipse will be partial. In Sydney there will be, at most, about a 19% coverage starting at 1:37pm. Dr. Kat Ross at the International Centre for Radio Astronomy Research added that this is another wonderful example of the incredible role WA has in observing our local astronomical neighbourhood and exploring the depths of our universe. Professor Melanie Johnson-Hollett at the Curtin Institute for Computation is eagerly awaiting Thursday, noting that this is a tangible experience that demonstrates the structure of the solar system and that we are on a rock being orbited by another rock, both of which are orbiting a star in the vastness of space. And we will be live on Trekzone TV from 11:30am Australian Eastern with a view of the eclipse, weather pending of course. It's all thanks to timeanddate.com and the Perth Observatory. Jump onto the trek.zone/TV or head to our Facebook event. Well, Sierra Space in the US is hoping to launch cargo to the space station no earlier than December. If the Vulcan Centaur rocket from United Launch Alliance and their own Dream Chaser shuttle can be certified by then. The orbital spacecraft is designed to land on conventional shuttle runways to conclude its missions, with test flights deemed successful. The design of the 9-metre-long craft was inspired by both NASA and Soviet blueprints, with the 1980s-era American HL-20 a key influence. Sierra Space's ambition stems from the Commercial Crew Program, which saw NASA farm out its space station crew rotation missions to private companies. That contract, despite appeals and protests from Sierra Space, was awarded to SpaceX and Boeing, so Dream Chaser was modified to be a cargo transporter. In 2016, the Commercial Resupply Services 2 contract was won, with an original first flight due in 2018. Now ULA is waiting on Dream Chaser to launch the Centaur for the first time, hopefully by the end of this year. Well, for the first time in 65 years of exploration, the US is preparing to land an autonomous lunar rover. But it won't be NASA spearheading the mission. Instead, a group of students, faculty and alumni from Carnegie Mellon University in Pennsylvania. Setbacks in the American Space Agency's lunar agenda have pushed back the launch from late last year or early this year, as the rover will form part of NASA's Commercial Lunar Payload Services program. The mission heralds America's first robotic moon rover, with the Viper rover scheduled to launch in 2024, as well as the first student-developed rover. The 2-kilo robot, named Iris, has a chassis as big as a shoebox, with its carbon fibre wheels the size of bottle caps. Iris has been prepared for a 60-hour visual mission, snapping images of geographic features for study. While we'll be long gone from this planet before Andromeda and the Milky Way duke it out, we have got a front row seat to ARP 220's galaxies merging thanks to the James Webb Space Telescope. A 5,000 light-year wide area sees 200 star clusters packed in, with astronomers noting that ARP 220's central star-forming ring shines brilliantly, its light seen as 6 spikes ejecting out. With the merger, new stars have been forming at an intense rate thanks to an abundant gas and dust dust concentrated in the dusty central regions. Like its central region, it was a long-held theory that much of UP-220 hosts heaps of star clusters, but recent research analysing Hubble's pictures found the star formation shut off suddenly everywhere about 100 million years ago, likely as a consequence of the merger. The location of the brightest cosmic explosion ever recorded has been pinpointed at 2.4 billion light-years from Earth. The blast, known as a gamma ray burst or GRB, was first picked up by sensors on Voyager 1 last October, only arriving at Earth 19 hours later. It was then detected by several gamma ray space telescopes, including NASA's SWIFT and Fermi, and the European Space Agency's Integral. But two papers published this week show it was spectroscopic data collected by the European Southern Observatory's Very Large Telescope that finally helped locate the origin of the blast in a previously unknown galaxy. Scientists believe the blast was as bright as it was because of its relative proximity, and also that the beam of radiation was pointing in our direction. It was also detectable for an unusually long time. Gamma ray bursts can last from milliseconds to a few hours, but this one, designated GRB 221009A, could be observed for 10 hours. The paper identifying the location of the blast involved 42 scientists from 30 research institutions around the world. It's been peer-reviewed and accepted for publication in the journal Astronomy and Astrophysics. Well, international researchers suggest that the planets surrounding a star with a low metal content are the most likely candidates for our search for life in the universe. The team modelled hypothetical Earth-like planets around different stars containing various levels of metal and say the planets orbiting stars with lower metal content have better shielding from UV, which would give them a better chance for potential life. They say that while metal-rich stars emit substantially less UV radiation than metal-poor stars, the surface of their associated planets are exposed to more intense ultraviolet radiation. The authors suggest that planets orbiting metal-rich stars are less suitable for life despite receiving that relatively less UV radiation. Well, our podcast offering is now live. Find each of Trekzone's shows on Google or Apple Podcasts, Spreaker, iHeartRadio, and more. You can also find our channel now in the iTunes library for a one-stop shop for all of Trekzone's goodness. Don't forget our solar eclipse live stream on April 20 from 11:30am my time on Trekzone TV or in our Facebook event. We'll also have the pictures wrapped up on next week's Talkin' Science. Memberships are available both for early access and behind the scenes for our next Star Trek fan film, and our social media feeds have the podcast highlights and Star Trek episodes. Hey, let's get engaging. What's got you excited in today's stories? See you in the comments on YouTube and over at Spreaker as well.